Mars Landing Vision, MLV, which is like an AI-powered safe landing on Mars by me. And so MLV is a computer vision project which is designed to identify safe landing zones on Mars. It uses AI to classify Mars terrain from surface images and includes a real-time dashboard to visualize landing zone safety. And so I like our team built it to reduce the risk of spacecraft crashes during landing, which is like, as I said before, like one of the hardest parts of the launch. So like right now, yeah, exactly. So the problem landing, like a huge problem right now is landing on Mars is very dangerous. So like you can't, so on Mars is so far from Earth, so you can't like have real-time communication or updates. And there's no like GPS, so you can't like just like, because that comes from satellites, right? And the satellites are so far away. So there's no like real way to like land like with real-time communication. You kind of have to pre-program it. And like if not pre-program it, you could use an ML model as well to like learn. And so the signal delay from between Earth and Mars can be up to 24 minutes. So no human can intervene in time to like adjust the spacecraft to land properly. And then a single bad landing zone decision can destroy the entire mission. And then there are many terrain hazards which include rocks, craters, slopes, and loose sand. So a solution could be teaching AI to read the Martian surface. MLV uses a residual network or ResNet 18 to analyze Mars surface images. The AI learns to recognize 8 different types of terrain. It can flag dangerous zones and highlight safe, flat ground automatically. The results are displayed instantly on the MLV Streamlit dashboard. And so MLV basically has like 8 terrain categories. So the terrain types include flat ground, rocky surfaces, sand dunes, slopes, and crater edges. And then each category carries a different level of landing risk. The AI assigns a terrain label and safety rating to every image it analyzes to like show the user where would be optimal to land. And so it's trained the ML model was trained on real Mars images from a data set I created. And so there's like thousands of real of the Mars images and 80% of the and it uses a 80-20 split. So 80% of the images are used for training and then 20% are for testing. And then the model adjusts itself after every mistake until it gets like the most accurate like results. And then the training stops when the model stops improving. Like I implemented early stopping so the model doesn't like overfit or like plateau. And so the ML model is a ResNet 18, which is basically a convolutional neural network or CNN with 18 layers. And so the network scans images layer by layer using kernels and picks up edges, textures, and shapes. Then it outputs a prediction of which terrain type it sees. And then the model is also optimized using the Atom optimizer and cross entropy loss. And so I had to also make sure MLV is like reliable with good accuracy and validation, because otherwise like there would be no point in it. Like if it has bad accuracy, there's like no, it wouldn't be accurate. Oh, wait. And so after every training session, the model was tested on images it has never seen before, and then this checks that it hasn't just memorized training data or overfit. And so the best performing version of the model is automatically saved, and the accuracy and loss are tracked every epoch to monitor progress. And so to display the results, I used like the MLV Streamlit dashboard. And so MLV includes a live interaction dashboard that was built with Streamlit. And so with the dashboard, you can upload a Mars surface image and get an instant terrain classification. And so the dashboard displays safety landing markers, which show like which zones are safe, risky, or dangerous, and they're all color coded. So blue is like low risk, green is like moderate risk, and red is like highly very risky. And then the color coded like visual overlays make it easy to interpret the results. And then it's designed to be simple enough for like scientists and mission planners to use like directly and effectively. And so for some real world use, MLV could be embedded in a Mars lander's onboard computer. And then during descent, it analyzes camera images in real time. And so the dashboard gives mission control a clear visual of terrain safety before touchdown. And then it works fully autonomously, which is like good because in space you can't have real-time communication, which is like so it means basically everything in space has to be done autonomously. And so there's a huge cost of like getting it wrong as well. So Mars missions cost billions of dollars and they take many years to plan. And a failed landing basically means the entire mission goes up in flames and the spacecraft is basically gone and all the scientific instruments. So like there's been many past failures like the Schiaparelli lander crash and which highlight how critical landing is. MLV exists to reduce this risk with intelligent data-driven decisions. So here's the future of MLV. MLV can be expanded to other planets and moons like Europa, Titan, and Earth's moon. And versions could combine terrain location with the 3D like showcase like on a 3D like scale where to land. And then it could be integrated with autonomous drones as well that scout landing zones ahead of the lander. And then it can contribute to the long-term goal of crewed Mars mission or Mars missions that work on inhabiting Mars or bringing people there. Because right now we haven't brought any people to Mars yet. And so here's some key takeaways. So the Mars Landing Vision, or MLV, uses AI to make spacecraft landing safer. It classifies 8 types of Mars terrain from surface images. It's trained on real Mars data and validated for reliability. And it uses a live Streamlit dashboard to display safety markers and terrain results visually. It's a step forward in AI-powered planetary exploration. And so this is like so for the future for human Mars exploration, it bridges the gap between raw Mars imagery and safe mission critical decisions. And the project demonstrates how AI can operate where humans cannot. And yeah, that's it. Uh, oh, I also right here is like the dashboard, and so uh I can like upload an image. So I have this one saved, and it will like it's currently analyzing, but then it'll like display the results. So this image is like very safe. So like you can almost land like anywhere in the image, but then you can see like with the color coded, like there are some spots where it could be hazardous. And then here's the GitHub repo with all the files I used.
Okay. So, can you just take some random images for online and can you just upload it
Sure.
now? I just want to see how it works.
Yeah. Let's see. Yeah, so this image is like very safe. So almost there's no red, I think, or there's barely any red. So like you can almost
It's
land like
minimal.
anywhere. Yeah.
Okay, great. So, like, there are any some description regarding the landing or something else, or like it's enough from this side.
So it gives like an AI insight, which like the landing zone is highly safe with minimal terrain hazards. And so like I don't know, like with the obviously like a way more hazardous image, this would change. Like maybe
Yeah,
like this.
yeah. Just do it.
I don't know though, because like we may think it's hazardous, but in reality it might not be. So
Okay.
let's see what it says. Hmm. Okay, yeah, let's. Okay, let's look at a different one. I don't know. This one's not saved. Like,
Okay. Yeah, try it. I think so. There's already a.
yeah, there's already something in there, so it might like mess up. I
Yeah.
don't know.
Try this one.
Uh, this one
Yeah.
looks. Oh, it's also. Oh, that's why. I forgot to check the file type. It can only be JPEG, JPG, or PNG. I don't think.
Okay. Let's search for more.
Yeah, these are WebP. Okay, they have to be.
Like, I can you just let's just search Pixabay, Pixby,
PIX.
A B Y BAY. Yeah. Uh, just open that. Yeah. Just search here.
These look AI
Mm,
generated. Okay, this one
yeah,
looks good.
yeah. You will find PNG and JPG, they are not copyrighted also.
Oh wait, this is web. Okay, this.
No, no, it's coming. Yeah, it's JPG.
Oh, okay, nice. Let's look.
Yeah. Okay.
Yeah, so I guess so these spots seem to be less hazardous, and then this like area could be more hazardous, but it's still like relatively safe.